Alright, in 5-6, we got two more types of quadrilaterals left. No more parallelograms. So both of these types are not parallelograms. So these are a little bit different than that. So all of those properties of parallelograms don't exist for any of these problems, so you got to get those out of your head. Okay. The first one is a trapezoid. Right, you might have seen a trapezoid before. A trapezoid is just a quadrilateral with one pair of parallel sides. Right, one set of opposite sides being parallel. Okay, so if you look at our little diagram over here, we've got these two bases. The parallel sides are called the bases, are parallel, but if you look at SR and TU, definitely not parallel, so not a parallelogram. Okay, the mid-segment, or the median, right, of a trapezoid is basically the midpoints between the two bases. All right, so if I connected the midpoints, that would be the mid-segment or the median. Okay, it's not drawn on there, right? I just drew it, but that's what that would look like. That leg thing is just arrows. That's not an actual line. Okay, so we'll talk about the mid-segment, but what it's basically going to be is going to be the average of the two bases. So you add the two bases up and divide by 2 in order to find the mid-segment. I'll show you how that works down at the bottom of this page. Okay. Lastly, if you happen to have, you don't necessarily have to have these opposite sides congruent. If you don't, still a trapezoid, right? But if they do happen to be congruent, then it's going to end up being an isosceles trapezoid. Okay, so an isosceles trapezoid has a couple of things true. Right, it's got those sides true, and because those are true, right, we also are going to know that these base angles are going to be congruent as well. So these are going to be congruent to each other. Okay, just like that. Also, the diagonals are congruent. So if I drew SU and RT, those would be congruent as well if it was an isosceles trapezoid, not if it's just a regular trapezoid. Okay, so a couple of examples right off the bat. All right, the first one, first two actually, all right, we need to pretend like these are isosceles trapezoids. Okay, so these are isosceles. All right, since these are both 5, it's going to be isosceles as well. Alright, so we know a whole bunch of things about isosceles trapezoids, about their angles. Okay, so we know that the consecutive angles are congruent, so we know this one has to be 125. Right? But we can also find the measure of angle C and angle D, right, by the fact that consecutive angles are going to be supplementary. Okay, these ones next to each other are going to be supplementary to each other, right? That has to do with the parallel lines and the consecutive interior angles. Alright, so if you subtract from 180 for both of these, you're going to get 55 degrees. So the measure of angle D is 55 degrees. All right, in L, all right, in the second one, all right, we again know that since K is 40, J is also 40. All right, and the other ones add up to 180, so 180 minus 40 gives us 140. All right, what gives us the measure of angle L as 140. Okay. Now for these coordinate geometry ones, right, if we want to show that they're in a trapezoid, that means you got to find slopes, right? The only thing we know about trapezoids is that they have one pair of parallel opposite sides. Okay, so if you find the slopes of all these, one side should come out the same. So let's find this slope of AB. All right, slope of AB, you're going to count, you're going to go up 1 to the right 4, up 1 right 4. It's going to give us 1/4. Slope of BC, you can probably see which ones are parallel and which ones are not based off this, but you need to count it out just to make sure. You're going to go down 1, 2, 3, 4, to the left 2. So you got negative 1/2. Slope of CD, right, going up 1, left 4, so negative 1/4. And lastly, the slope of AD, this is where we're going to get our parallels. You're going to go up 2/1. Oh, I wrote this one incorrectly. It should have been negative 2/1. Right, and AD is also negative 2/1. Okay, so you see that you've got one set of parallel lines, so because of that, it's definitely a trapezoid. Now to figure out if it's an isosceles trapezoid, right, you just got to use the distance formula on the non-parallel sides to see if they're the same. Okay, so that's going to be AB and DC in my case. All right, so I need to find those distances and see if they're the same. So AB, we've got, you're going to go, the distance is 4 plus 1 is root 17. That's for AB. Right, and the distance for DC, or CD, is going to be 3 plus 1 is root 10. Since they're not the same, it's not isosceles. Okay, and number 4, exact same process, right? This one's a little bit easier because the distances are vertical and horizontal. All right, you see which ones should be parallel, so we could just go straight to it. that slope of JK should come out to the same slope as ML. Right, and we'll double check to make sure that's true. So they're going to go down 2 over 2, so JK is going to be -1. And ML is going to be down 2, 3, 4, to the right 4, also -1. Right, those are parallel, so we're good. The other ones are clearly not parallel, they're going to be undefined and 0, but you'd write that out as well. Alright, then you do have to find these distances to show that it's an isosceles trapezoid, if it is. So the distance of M to J, right, you just count, and it's 3. And the distance from K to L, K to L, count straight up, it's also 3, so since it is 3 as well, right, this one is an isosceles trapezoid. Okay, lastly, working with the midpoints, the medians or the mid-segments. Okay, so we've got, I'm going to do a little erasing. Oh, I can't. No need to erase, you can see it up there. Alright, so first one tells us that HJ is 32, right, and LK is 60. It wants to find MN, right? So the way you find MN, right, that mid-segment or the median is just the average of the two that we have. So if you add those two up, 32 plus 60 divided by 2, right, that's going to give us our MN, right? That comes out to 92 divided by 2, which comes out to 46. Right? That's good stuff right there. Now, if we have the median, we need to find one of the ends. It's just like finding when we work backwards with the midpoint. Okay, so if MN is 28 and HJ is 18, let me show you how I suggest you do that. Rather than plug it into a formula and do complicated algebra, right, think of it this way. Think of it as going from the side to the median, right? You're adding 10 here, right? Remember that's like a midpoint, so you just have to do the same thing. Again, add another 10. Right? If we were subtracting 10, obviously we would subtract another 10. Right? So if you add 10 to get from 18 to 28, add another 10 for LK, and it's going to be 38. Now, working with kites. The thing about kites is they look even more weird than the ones that we've talked about already. Okay, again, not a parallelogram for sure. Right? You look at this and you see that there's not going to be anything parallel or anything like that. Right? What you do know about a kite is the consecutive sides are congruent to each other. Okay, so look at those ones that are congruent to each other. Right, you're also going to have one set of opposite angles. So if you look at the ones that connect the two, right, those are going to be congruent. R and N are definitely not congruent. And the last thing you know is the diagonals are perpendicular. Okay, so these three things are the ones that you know. Okay, so from that you can solve a bunch of different things. Alright, there's two of these that, because we've got right angles, again, they're using the Pythagorean theorem, which is fine. You can do this if you want. I'm not going to hold you to that, right? But if I find just the measure of JRK, right? JRK is right here, right? One of our three properties of kites is that the diagonals are perpendicular, so you know that has to be 90 degrees. Okay, number 2 is one of our Pythagorean theorem problems, so you don't need to worry about that. Right, don't need to worry about that. This one's the same. Right, you shouldn't need to do this. Right, and number 3, right, JHJ, is 90 degrees. Right, this one we're not going to use the diagonal, so just kind of forget that they exist. And GKJ is 110. Right, I know it's not drawn to scale, definitely doesn't look like that, but got to bear with them on this. Okay, so for these types of problems, if you have the top and the bottom angles, the big angles, and they're not the same, all right, then you know that the other two have to end up being congruent, because there has to be one set of opposite angles that is congruent for a kite. That was one of our properties we talked about above. Okay, so what that means is these two angles, the 110 and the 90, right, that use 200 of our 360 degrees for our quadrilateral. Okay, so that means that the final 160 degrees that we have allowed has to be split evenly between angle G and angle J. Okay, so because of that, what we need to do is take 160 divided by 2 to divide it evenly, and you get that both of them are 80 degrees. Right. We'll do one more like that at the bottom of this page. And number 4, right, if hj is 7, right, then gh is also going to be 7, right? Remember, we've got one set or two sets of consecutive sides being congruent. Okay, so those are an easy problems to solve. Lastly, all right, one of those angle problems again. All right, this one comes out with some gross numbers, but we can still do it. All right, GHJ. All right, ignore the diagonals again. This one's 52. The bottom one is GKJ is 95. Once again, not drawn to scale at all, but trust the process. All right, so you know that these two angles have to be congruent. They have to divide evenly whatever is left. All right, so when you add those up, you get 147. Subtract that from 360, all right, because that uses 147 of our 360. The final 213 that we have left has to be divided evenly between those other two. Okay, so you got 216 degrees to divide evenly between angle G and angle J. So if you divide 213 by 2, you get 106.5 for both of those angles. Okay, both come out to 106.5. All right, and just quickly, because we have a moment, if you want to see how to do those Pythagorean theorem problems, right, I'll do those really quickly right now. So for number 2, all right, if Rj is 3 and Rk is 10, all right, you know you've got a right angle here, so it sets up our Pythagorean theorem really nicely. Okay, so to find Jk, you've got 3 squared plus 10 squared. All right, you need to take the square root of that. It comes out to root 109. All right, which you could plug in a calculator if you needed to get around a decimal answer. All right, and lastly, this other one, we've got Hg is 7, Gr is 5. We want to find Hr. Once again, Pythagorean theorem. We're going to work the opposite way this time. All right, for this one, we've got the long one, the hypotenuse. So 7 squared minus 5 squared is going to give us our answer. So we've got 49 minus 25 comes out to root 24. All right, and root 24, remember from our practice from before, reducing radicals reduces to root 6.